Okay, so we have work, energy, and power. So we will start with some definition. We will each define work, energy, and power. So as you know, work, energy, and power are physical quantities that are used to quantify a certain measurement. Okay, so work, energy, and power are all scalar quantities. Okay, so they can be fully described or they can be um they can be fully described through its magnitude and a unit. So naa kay number and a unit. So work is the product of force applied in an object and the distance it is moved. Okay, so later we will have the mathematical expression for work. So it is defined as the product of the applied force in an object and the distance it is moved. While energy is the ability to do work, and power is the rate at which work is done. So power involves time. Okay. So work, 'di ba? Ordinarily, ang work class is any activity that requires muscular or mental effort. So say for example, I can say nga ga-work ko karon since nag-ingani ta na nag-discuss ko sa inyo, I am working. It may also mean any activity for which a payment is received. So that is kanang definition sa work. But in physics, ang work kay na siya precise nga definition. So when we say work, it should involve a force and a movement that is in the direction of the force. So say for example, kini akong gibuhat karon class, since I am not moving, then uh sa physics pa kay wala na siya work. Work is equal to zero. Okay? So for example pod, you are trying to push a big boulder of rock, and then you apply a force that is grabe ka dako nga force, say for example 10,000 newtons of force, but the rock kay wala siya nag-move. Bisan pag nagkagidlay na ka dira class, nagkagidlay na ka og push ani nga rock, nagtulo-tulo na imong singot, nagtulo-tulo na imong singot og push aning boulder of rock. Since ga-apply ka og dako nga amount of force, then walay work done due to the applied force. Okay? So work done due to the applied force is equal to zero. Okay? So bisan pa og kanang nagsakit na imong kamot og tinuklod aning big boulder of rock. Okay? Now consider an object that undergoes a displacement d. So take note that displacement and force are both vector quantity. So for example, if we have an object, say for example, a wood na siya sa ground, and then it undergoes a displacement d when applied by a force F. So say for example, this wood displaced by this amount D, kini siya nga displacement. When you apply a certain amount of force, say for example F, denoted by F. Okay? The force here is some theta degrees from the positive x-axis or from the horizontal. So it is mura siya so na siya certain angle with respect to the horizontal. Now, the work done by the force can be expressed by taking the dot product of force and the displacement. Okay, so in our first unit, so we have discussed there the dot products. So work, which is a scalar quantity, can be expressed as the dot product of two vectors, specifically the force vector and the displacement vector. Okay. Now, by definition of the dot product, work can be expressed as, so ito, basta dot product, you can get the magnitude of the force vector multiplied by the magnitude of the displacement vector multiplied by cosine theta, where theta is the angle between the displacement vector and the force vector. Okay. So take note that theta here is defined as the angle that is between the force vector and the displacement vector. Okay. Meaning to say, when for example, if the force vector is parallel with the displacement vector such that your theta is equal to 0, then your work, the work is equal to, so na kay F times D cosine 0. Cosine 0 is equal to 1. So you have work is equal to F times D. Okay. So this is the magnitude of the force and multiplied by the magnitude of the displacement. Okay. But if, for example, if the force is parallel with the displacement, okay, the force is perpendicular with the displacement vector. So say for example, nakakaingani nga force upward, and then the displacement is going there, the displacement is there, such that they are perpendicular with each other. Then the work done by that force is equal to, so in this case, theta is equal to 90 degrees. Then the work done is equal to FD cosine 0, where cosine 0 is equal to 0. It's 90 degrees is equal to 0. Cosine 90 degrees is equal to 0. So the work done by that force is equal to 0. Okay? Now, work is a scalar quantity, but it can be negative. So what are the cases wherein the work done by a force is negative? So kano saan na siya mahitabo? Any idea, class? So again, even though work is a scalar quantity, it can be negative. And negative work implies that, ano saan negative ang work, class? Work done on an object can be negative. Okay. So, for example, if the force is opposite with the direction of motion, for example, sa previous na tong example class, we have the frictional force, wherein it is called an antagonistic force because its direction is always opposite to direction of motion. Okay? So the displacement, for example, if you have a block that is moving to the right in a rough surface, Then, nakay displacement that is going to the right and frictional force that is going to the left. So the work done by the frictional force there is negative. So if F is anti-parallel with D, or bisag dili siya anti-parallel, if the angle between the force and the displacement is more than 90, sakto ba? Between 90 to 180 degrees, then we will have a negative work. Okay, so naakay if F is anti-parallel with D, then theta is equal to 180 degrees. So we have we have work is equal to FD cosine 180 degrees, where cosine 180 degrees is equal to minus 1. So we will have work equal to minus force times the displacement, magnitude of the displacement, okay? So take note that these are the magnitude of the force vector and the displacement vector. Okay? Uh, how about the unit of work, class? The unit of work. Now, we define work as katong kaganina, ang qualitative nga description or ito, you can multiply the force and the displacement. Force has units of Newton, and then displacement has units of sa units sa displacement class. Apa ko? Okay,
Meters, ma'am.
meters. So work has units of
Joule.
Newton, yes, Newton meter, which is when we have 1 Newton meter, this is equivalent to 1 joule. 1 Newton meter is equivalent to 1 joule. Okay. Okay, so let us have an example here. We have a janitor cleaning a floor in the physics department room, pulls a vacuum cleaner with a force of magnitude. Okay, so we will have this example wherein we have a janitor that is cleaning a room. Okay, and then he uses or she uses a vacuum cleaner. And then the janitor applies a force of magnitude 60 newtons at an angle of 25 degrees. So we have here the vacuum cleaner, for example, this one. And then, yeah, ang applied force is 60 newtons, 25 degrees above the horizontal. Okay, so F equals 60 newtons. And then we have 25 degrees na angle. Find the work done by the force on the vacuum cleaner displaced 250. So this vacuum cleaner is displaced 250 centimeters to the right. 250 cm to the right. Okay. So first, we have to draw the free body diagram for this problem. So nakay free body diagram. What are the forces acting on the vacuum cleaner class? What are the forces acting on the vacuum cleaner? first we have the normal force, and then we have the gravitational force. And then we also have the applied force. Okay, so here. So the applied force is equal to 60 newtons and then 25 degrees from the positive x-axis. Okay, so what is the work done? So for this problem, we just have to substitute what we have, what we are given with. So we are given with the applied force, the displacement, magnitude, and then we have the angle theta. So we have force, which is 60 newtons, multiplied by the displacement magnitude, which is 250 centimeters. Now take note that we should convert this into the standard SI unit for displacement. So that is meter, that is equivalent to 2.5 meter. You just have to multiply this with our conversion factor, wherein 100 centimeters is equal to 1 meter. And then we have cosine, the angle 25 degrees. Okay. So this is equal to 136 Newton meters. Or we can write this as 136 joules. Okay. Now, how about if we have several forces? Work done by several forces. So if we have several forces, for example, we have a problem. A CMU farmer hitches the tractor to a sled loaded with sacks of rice and pulls it a distance of 50 meters along level ground. The total weight of sled and load is 12,000. So we're given with the weight of the sled and the load, which is equal to 12,250 newtons. Uh, and the tractor exerts a constant force. So naatay F applied by the farmer or the tractor of 4,000 newtons at an angle. So this is at an angle 40 degrees above the horizontal. Okay, so there is also a 2,400 Newton friction force. So we are given with a frictional force, which is 2,400 Newtons, opposing the sled's motion. So of course, frictional force, the direction of the frictional force is opposite to the direction of motion. Now we are asked to find the total work done by all the forces. Okay, so first we have to make a free body diagram out of the situation. All right. So here we have the weight in the positive y-axis, in the negative y-axis, the normal force in the positive y-axis. Okay, so we have the normal force, the weight along the vertical axis, and then we have the frictional force, which is opposite to the motion. Now, if the tractor is going to the right, then si sled pod as well as the load will go to the right. Okay, so the displacement of the object is going to the right. Therefore, frictional force is going or is directed to the left, the negative x-axis. And then we have the applied force, which is 4,000 newtons, and then directed 40 degrees above the positive x-axis. So this is 40 degrees. We have here the applied force. Okay. Now, here we will use Newton's laws of motion. Okay? So, ang first na tong approach class is to get the net force. Okay? So, in order to solve for the work done by several forces, we will have to take note class, ang ipangutana kay calculate the total work done by all the forces. Okay, so for this problem, we have to know the total force nga naa sa system. Okay? Since ang ipangita sa to kay total work done by the forces. Okay? So we have to know the net force. So in doing that, we will use Newton's laws of motion. Okay, so we have the first law. If you can recall, we have summation of forces, or the net force is equal to 0 if, sa ganito class, what is the condition for equilibrium? If the object is at rest or it is moving at constant speed. And then summation of force is equal to MA if the object is sa class accelerating. Sakto na pa mo class?
Yes, ma'am.
Hello, Philippines.
Yes, ma'am.
Wala pa, ma'am.
Okay, so we just have to get the total force class. No need for this equation. Okay, so we have forces along the x and then forces along the y. So summation of forces along the x is equal to, you have the positive component of the applied force. The x component of the applied force. So we have F applied along the x minus the frictional force. Sakto? And then, kinilang duha ang along the horizontal axis. And then we have summation of force along the y. This is equal to what are the forces along the y class? Forces along the y, we have
Normal force, ma'am.
okay, the normal force minus the weight, and then we have the positive kining weight class man ni siya si gravitational force. And then we have F applied, which is along the y. The y component of the applied force, the tension. Now take note that the summation of forces along the y is equal to 0. So there is no displacement along the y. So this is equal to 0. Okay. So we have kinilang. We have this one. Now we are given with the applied force The applied force is equal to 400 newtons. And then since this is the x component of the applied force and it is adjacent, so this one, this is your F applied of x component of the applied force adjacent to your angle theta. So this is 400 newtons cosine 40 degrees minus the frictional force. So the frictional force is pila ito itong frictional force? 2,400 newtons. Okay, so this is equal to pila ni siya class? Your summation of F along the x is equal to, do you have your calculator? This is 600, 6, pila ni siya class?
66418, ma'am.
Okay. 664
0.18.
0.18 newtons. Okay, very good. So summation of force along the x is equal to 664.18 newtons. And again, your summation of F along the y is equal to 0 since there is no displacement or walay motion along the y. Okay, so after this, after getting the net force, we will then get the total work. So, pwede na to kuhaan ng total work class. So, take note, di ba diri ang displacement? So, we can see here, kung diri pa dulo ang displacement class sa positive x-axis, then, most likely, the work done by the normal force is equal to 0 since it is perpendicular with respect to the motion. The work done by the gravitational force is also equal to 0 since it is perpendicular with respect to the direction of motion. Okay? So, the forces along the y will not have wala sila contribution sa total work done. Okay? The work done by the normal force is equal to the work done by the gravitational force, which is equal to 0. Okay, so the total work, we denote it as W sub T, total. This is equal to the summation of force, the net force, dot with the displacement vector. Or this is just equal to the magnitude of the net force times the magnitude of the displacement multiplied by cosine theta. Now here, theta is, take note class nga katong atong f sub x kaganina, this is directed along the positive x-axis. So, kung i-write ni siya nato in vector form, this is 664.18 newtons I hat. Okay? Kaya mas, I hat. And then we have the displacement vector that is also going to the positive x-axis. So, are we given with the displacement class? 50 meters, yes. So the sled loaded with sacks of rice and it has been pulled at a distance which is equal to 50 meters along the ground. Okay, so we have the summation of force, 664.80 newtons multiplied by 50 meters. And then we have cosine 0. So this is just F times D, summation of force, the total force times the distance. So we have Uh, this is 33,200, approximately 33,200 Newton meter. 33,200 Newton meter or 33,200 joules. Okay, so do you have questions, class? Okay. In some problems, dili ang total work ang pangitaon. For example, what is the work done by the applied force? So we just have to uh, calculate the work done by the applied force. Pwede po, what is the work done by the normal force, the work done by the gravitational force, and the work done by friction. Okay? So, naingan ang mga problems. So, for example, let us get the work done by friction here. For this problem, so this is the total work. Okay, please take note of this. And then, for example, what is the work done by the normal force? So work done by the normal force, are we given with the normal force? We can get the normal force, by the way, class. You can get the normal force using this equation. Okay, so you can transpose F applied along the y in the right-hand side of the equation, as well as the weight in the right-hand side of the equation. And then normal force is just equal to F applied along the y, the negative of this, plus the weight. Okay, so using this equation, we can get the normal force. So let us just try to solve this one. So normal force is equal to the weight minus F applied along the y. So this is equal to, the weight is given, are we given with the weight? The weight is 12,250 newtons minus F applied, which can be obtained by this 4,000 multiplied by sine 40 degrees. Can you calculate this one, class? How much did you get? How much force? The normal force is equal to
9,668.
9,169.
okay. So 9,679. Sakto ba, class? Newtons. Okay, 9,679 newtons. Therefore, the work done by the normal force is the normal force multiplied by the displacement, the magnitude of the displacement, and then we have cosine 90 degrees. So this is regardless kung unsay value sa imong normal force, class. Pakita lang nato nung nga zero siya. We have the displacement, which is 50 meters. Magnitude of the displacement vector. Cosine 90 degrees, which is 0, so we will get 0. The work done by the normal force is 0. Now, the work done by the gravitational force. The work done by the gravitational force is just equal to the weight multiplied by the displacement magnitude cosine 90 degrees. Okay, so no matter what the weight of the object is, it's 12,250 newtons multiplied by the displacement magnitude multiplied by 0. This is also equal to 0. And then let's have the weight, let's have the work done by the frictional force. Okay. For the frictional force, we just have to multiply the magnitude of your frictional force by the displacement. And then we have cosine cosine 180 degrees. Take note that they are 180 degrees apart. So from our kung diri padulong ang motion, kung diri ang direction sa imo ang motion class, then this is 180 degrees. 180 degrees, the angle between them. Okay, so we have negative F times D, since cosine 180 degrees is equal to minus 1. All right, so we have the frictional force, which is equal to 2,400 newtons multiplied by 50 meters. So this is the work done by the normal force, and it is negative. So you have 2,400 times 50. We have 120. 120,000. Okay. And then this is negative 120,000. How about the work done by the applied force? Work done by the applied force. So this is equal to F applied multiplied by the displacement magnitude, and then we have cosine 40 degrees. Okay, so we have 4,000 newtons multiplied by 50 times cosine 40. So this is equal to, so we have 4,000 times 50 times cosine 40 degrees. So we have 153,208.889 newtons. Okay, now if we add all of this is the total force. Okay, so if we add all of this work, this is the total work. So nakay total work, let us write it here. The next page na class. Okay, so work total is equal to the work done by the normal force plus the work done by the gravitational force plus the work done by frictional force plus the work done by the applied force. Okay, so let us see if we will get the same answer. So this is 0 plus frictional force is negative 120,000 newtons. And then the applied force is 153,208.89 newtons. Okay, so here we obtain 33,208.89 newtons, which is equivalent to what we have obtained in the previous. So using katong gisam sa nato daan ang forces, so we have obtained first the net force, and then you multiply nato ang displacement, the magnitude of the displacement. Okay, so the same answer. All right. Do you have questions, class? Do you have questions?
Wala naman.
If wala, then let's proceed to work and kinetic energy theorem. So, unsa man nga theorem? Work kinetic energy theorem. Before that, let us define first kinetic energy. So, unsa man kinetic energy? Again, energy is the ability to do work. And then we have two types of energy, kinetic energy and potential energy. Okay, so the kinetic energy is associated to the motion of an object. So kinetic energy is the energy that is associated to the motion. Energy associated with the motion of an object. So any moving object has kinetic energy. Okay, so all objects in motion have kinetic energy. And of course, like any other types of energy, kinetic energy is a scalar quantity and it is given by this. Kinetic energy is equal to 1/2 multiplied by the mass multiplied by the speed of the object. So take note that, it is really associated with the motion of an object. If the object is at rest such that your V is equal to 0, then your kinetic energy is equal to 0. So, naalang si kinetic energy kung imong object ay nag-move. Okay? And take note that it is independent of the direction of motion. Now, according to the work kinetic energy theorem, it states that the total work done by the net applied force in an object is equal to the change in the object's kinetic energy. Okay? So, the work kinetic energy theorem states that the total work done by the net force, total work done by the net force is equal to the change in its kinetic energy, in the object's kinetic energy. Or in order to simplify this, we'll have the mathematical expression. So the total work done is just equal to the change in kinetic energy. When we say change, this is equal to the final kinetic energy minus the initial kinetic energy. Okay. So, kini lang. Makuha na to diretso di ay ang total work done sa isa ka system if we know the final and the initial kinetic energy of the system. So, we just have to subtract the initial kinetic energy from the final kinetic energy. So, that is the total work done in an object. Okay? So, this is the work kinetic energy theorem. And then, you might be familiar with the conservation of energy. So it says the conservation of energy says that energy cannot be created nor destroyed. So I guess you are familiar with this one. Energy can neither be created nor destroyed, but it may be transformed from one form into another. But the total amount of energy remains the same. So, for example, for a given system class, for a given isolated system, energy cannot be created nor destroyed, but it may be transformed from one form into another. So, meaning to say the total energy of a system that is isolated is constant. Okay? So that when you get the total energy before and after kung nakay intervention nga gibuhat sa imong system or naay nahitabo before an event sa imong system, the total energy of that system is constant. kung imo siyang i-minus, the total energy before and after is equal to 0. So, total energy after minus total energy before is just equal to 0. Okay? So, conservation of energy, energy can neither be created nor destroyed. So, mathematically, we have E, the total energy after, or the final total energy of a system is just equal to the initial total energy of the system. So, for example, the energy sa universe sa una hangtod karon kay constant because energy cannot be created nor destroyed. So, for example, so may good example ani class. So, say for example, na collision class, say for example, na kay moving object. So, kung na kay moving object such as a car, it has kinetic energy in it. Okay? And then, collide siya diri aning big boulder of rock. So, diri. Okay? Now, si car class, upon collision, matingala mo kay, of course, mo-stop siya, no? Na ay certain point nga mo-stop siya. So, ako man ipadulong dayang kinetic energy. So, we have kinetic energy, very huge kinetic energy. So, say for example, it is moving at a high speed before it crashes the big boulder of rock. Okay? And then at this point, so this is the kinetic energy before, so the initial kinetic energy. And then at this point, katong nabangga na siya, nakay kinetic energy after. Okay. So here we can say, since the car is at rest na, kanang nabangga man siya, so mura siya nahunong, stop, it comes to a stop. The final kinetic energy is equal to 0. Now, dili na to makita ang conservation of energy. Sakto ba? But, this is the law of nature. The law of conservation of energy. Now, kini siya class, the kinetic energy nga nasa iya initially, kaya transform lang into other form of energy. So, say for example, it transforms into heat. So, pagbangga niya, na 0 ang iyang kinetic energy, pero niinit siya. So, ni-transform iya ang kinetic energy to some other forms of energy such as heat. Okay? So, the total energy before and after the crash is just equal. All right. Now, take note that this, kini siya, the law of conservation of energy is applicable to conservative nga system. So, sa mga conservative nga system class, we should not take into account, say for example, friction. So, walay friction. So, in the next lesson class, we will have momentum and collision. So, there, we will make use of the conservation of energy. Okay. Now, the total energy of a system is just equal to the total energy, E total. So, di ba na kay conservation of energy, which is equal to this one. Na kay the final total energy of a system is just equal to the initial total energy of the system. Your total energy is an account of the total kinetic energy and the total potential energy of the system. So naa kay kinetic energy plus potential energy. Okay, so in the next meeting, we will have um, the two types of potential energy class. Okay? And we will have examples, sample problems. I hope sa next meeting class kay malantaw na ninyo ang video. Okay, so this will be all for today, and then see you in the next meeting. Do you have questions?
No, ma'am.